Good afternoon. Good afternoon, sir. Yeah, my name is Collins Kirui. I'm presenting an innovation of a project of our group, which is YGS. Yeah, on my part, I'm going to present a project on utilizing peppermint sludge and polyester fibers for a lightweight concrete to reduce cracking and enhance mechanical properties. As you know, day in, day out, we carry out innovation, we carry out invention. We try to improve the existing material in the construction industry. As you know, years in, years out, in the construction industry, we've been faced with different challenges. And as engineers, we are trying to come up with new materials so that we can help to cope up with the problems we are experiencing currently. So we carried out some research on this project, and we saw it's going to help to alleviate the current problem we are experiencing as a country. Peppermint sludge, when added to the concrete, it helps to reduce the weight of the concrete, which is helpful in non-structural buildings such as partitions, and that one helps in improving the longevity of building. On the side of polyester fibers, the use of peppermint sludge and polyester fibers create what we call synergistic effects. Synergistic effects is a process whereby the problem posed or the problem introduced by peppermint sludge can be counteracted by polyester fibers. On the same note, the problem also introduced by polyester fibers can also be counteracted by peppermint sludge. For example, the use of polyester fibers itself cannot help to produce a lightweight concrete, maybe unless you replace it with higher percentage of polyester fiber, so which it's impossible. So on the same note, on the issue of the use of peppermint sludge itself in concrete cannot help to improve its mechanical properties of the concrete, such as flexural strength, tensile strength, and compressive strength. So it is imperative also to use polyester fibers in the mixture of peppermint sludge. So we are in our project. We are going to mix cement, fine aggregate, coarse aggregate in the ratio of 1:2. So that is a mixed design we are going to use in this project of ours. Now, we are going to perform different tests in order to determine the different type of test or strength. On the part of mechanical properties, we are going to conduct flexural strength, tensile strength test, and in doing so, we are going to cast molds of 100 by 100 cubes, so that we measure tensile strength, flexural strength. We are going to test flexural strength. Let me start itself by flexural strength. We are going to, by each test, we are going to produce 3 moles, of which we are going to measure it at 7 days, 14 days, 7 days, 21 days, and 28 days, so that we can know the strength gainment in compressive strength. So, we're going to mix also peppermint sludge and polyester fibers. In the ratio, peppermint sludge we are going to mix at the rate of 0%, 5%, 10%, and 15%. On the other side of polyester fibers, we are going to mix it in the ratio of 0%, 5%, 10%, and 15%, so that we know at which strength or which percentage will give maximum strength. So on the same note, basically because we are going to mix it in a 4 proportion, we are going to produce 4 moles for each test. So to mean that if we are going to test at the rate of 7 days, we are going to produce for one test, we're going to produce 12 moles, so that we can test it the rate of at 7 days, 21 days, and 28 days. On the side of tensile strength, we are going to produce cylindrical moles of 100 by 150 millimeter, 150 millimeter diameter, and height is 100 millimeter, so that we test the tensile strength by use of tensile machine. On the side of cracking, so that we can test the cracking, we are going to use shrinkage trying molds and plastic shrinkage molds, of which we are going to produce on the side of shrinkage molds on 0%. We are going to test it consecutively, the reduction in length after casting a mold, concrete in a mold for 24 hours. So in each and every hour we are going to test the reduction in length. Same case to 5% of paper slightly and 0.1%. Same case to 10% with 0.2%. Same case to 15% with 0.3% of polyester fibers. We are going to do 2 sides. On the side of a plastic shrinkage test, we are going to perform 3 tests for each specimen, of which we are going to test it 3 tests for 1 specimen. So we are going to test it at 7 days, 21 days, and 28 days, and we are going to observe the effect of addition of paper sludge and polyester fibers on trying shrinkage, so that we can test the reduction or the point of reduction of paper sludge and polyester fibers on trying shrinkage test. On the part of I think I've tackled the part of on the part of comprehensive strength, we are going to cast for one test. We are going to cast for 3 moles for 7 days, 21 days, and 28 days, and also using different percentages of paper sludge and polyester fibers. Like as I said earlier, 0% polyester fibers, 0% paper sludge, 0.1% polyester fibers, 5% paper sludge, 0.2% polyester fibers, and 10% paper sludge, and 0.3% polyester fibers, 15% PMS paper sludge. I'm using such a percentage in relation to the weight of fine aggregates for paper sludge, and for polyester fibers, I'm using it in reference to a binding material, which is cement. So we are going to test for comprehensive strength for 7 days. With 7 days for 0%, 7 days for site replacement, 10%, 5% with 0.1%, 10% PMS, 0.2% polyester fibers, 15% paper sludge, 0.3% polyester fiber. Same case up to 21 days, the same case, 28 days site promotion I have stated. And finally, what the general outcomes of what we anticipated to get at the end of the project, we are going to expect an increment on the side of tensile strength. On the side of flexural strength, we are anticipating there will be an increment. On the side of crack resistance, we anticipate that there will be an increment over crack resistance. Also, on the side of compressive strength, we don't anticipate there is an increment, but we expect under maximum utilization of paper mill sludge, there could be a slight increment in compressive strength. And that is all. That is our project, and can say that is